All right, so this is our first lesson for Unit 3. What we're going to be talking about in this video is statistical investigations. Real quick though, I just want y'all to pause the video and look over all of these notes that are right here, all these definitions from observational study down to sample. Okay, so now that we've read all of the vocab, just real quick, I just want to give a little bit of a definition. Make sure that you know these symbols. So this symbol right here is called mu. It stands for the population mean, or in parentheses, I'm going to write average. And I'm going to say, put a little asterisk here, pronounced mu. All right, so that's population mean. The X with a bar on top, that stands for sample mean. Or average. And we usually pronounce this as X bar. Okay, so the mu is population mean. That is for an entire population of people or groups of items or things like that. And then X bar is sample mean, and that's usually a small group within the entire population. The X with an O after it, that is our null hypothesis. And then the X with an A is our alternative hypothesis. And we'll talk about these more at the end of the video. Now, statistical investigations. It says music is a large part of many people's lives. Because of this, it's often the subject of study. For example, music industry executives want to know what will be popular with different age groups. Advertisers want to know which radio stations are the most popular. Doctors want to know how much hearing damage results from loud music. And teachers want to know whether or not listening to classical music helps students perform better on tests. So stat investigations are used every day for a variety of reasons. What are some of the purposes of statistical investigations? Give some examples of investigations with which you are familiar. So answers here can vary. It's just dependent upon what you come up with. But something that I've come up with is stat investigations use a combination of math and science techniques to answer questions about human behavior effectiveness of medicines, safety of machines, and etc. So they're used for a giant group of basically anything and everything. If there is an item in this world, it's probably gone through a statistical investigation to see if it's the best thing for whatever use it's being used for. Now, we have a graphic here. It says this graphic illustrates the process of planning and implementing a statistical investigation. First, a question or a series of questions sparks the interest of a researcher. The researcher team then decides on the best design for investigating the question. And you can see it has question up at the top, and then they design something to be able to test it. Then they collect that data, they analyze the data, and then they report the data. And then they start over again with more questioning. So it says the graph shows no obvious ending point or starting point. And what does this mean? Well, that just means that you can start and end at any point in the problem. Okay, so just because you answered the original question does not mean that you are going to have even more questions by the time you end the experiment. So we can say for number 2, we can just write research can begin anywhere. Okay. You could be collecting data on one thing which leads you to question or research something else. Okay. And now it says, consider the following examples of 2 different types of statistical investigations. Example 1, radio rating services sometimes collect data on listenership by asking participants to record the date, time, and station each time they listen to the radio. Other rating services distribute monitoring devices that automatically record this information anytime the participant has the radio turned on. Still, others call participants and ask them about their listening habits. The data are then compiled so that advertisers know which stations are the most popular at specific times during the day. Each of these approaches is an example of an observational study. So I'm going to highlight that. This is an observational study, which collects data about some characteristics of the population. The data can be collected by observation, by a survey or interview, or by other means. So describe an observational study in your own words. So if we go back, the very first definition was observational study. It's it collects data about the population. So we can say, just in our own words, we can say data is collected by observing the subject in their normal routine. By observing the subject in their normal routine. And something specific to an observational study is that there is no attempt to influence the response. Okay, so observational study, we are just looking at what's happening. We're not implying or implementing anything into the study at all. We're not experimenting just yet. Now, example 2 says a 17-year-old student designed a science fair project with 72 mice and randomly assigned to 3 groups: hard rock music, Mozart, and no music at all. So the no music is what's called a control group. And the mice in the first 2 groups were exposed to music 10 hours a day. 3 times a week, all the groups were timed as they ran through a maze. An analysis of results showed that the 24 mice in the no music group averaged about a 5-minute improvement in their maze completion time, while the Mozart mice group improved 8.5 minutes. The hard rock mice actually got slower, an average of 4 times slower. Another interesting fact, the student had to start his experiment over because all the hard rock mice killed each other. None of the classical mice did that. This is an example of an experimental study. So I'm going to underline that, an experimental study. In an experimental study, the research separates the participants into 1 or more groups and applies some sort of treatment. After treatment, the variable of interest is measured and the results are compared. And it asks us, what are the treatment and variable interest in this case? So if we go back, just recap on what the student did. They separated the mice into 3 groups, one for each type of music and then a control group. And then they had them listen to music, and then they measured their times in a maze, right? So the definition for treatment is a situation imposed on a group by a researcher, and variable of interest is the response from the treatment. So in this experiment, the treatment is the type of music. Okay, so he's breaking them up into groups, and their treatments are, okay, you listen to hard rock, you listen to Mozart, and you listen to nothing at all. And then the variable of interest is the time it takes to run the experiment or run the maze. So time running the maze. Okay, so after the listening to music, he had them run the maze and he measured their times. And it says, describe an experimental study in your own words. So the original definition we had was researcher separates participants and imposes treatment. So what we can say is that there are at least two groups. There are at least two groups. And you always have to have at least one control. So we're going to say one must be a control group. Then a treatment is applied and results are compared. Okay. Now, the difference between an experimental study and an observational study, we don't do anything other than just observe. We're just collecting data that's already out there. Experimental study is where we impose treatments on something to get a reaction out of it. So an observational and experimental studies have many components that must be planned, such as sampling and data collection procedures. Then the data must be collected, the results analyzed, and the conclusions reported. Number 6 says, referring back to research cycle graphic, why is there an arrow after the report box? So here is report right here, and then an arrow after after it leading to question. And we kind of answered this a little bit in question 2, but basically it's research studies often lead to revised or new questions to be investigated. So whenever someone does an experiment like this high school student here in example 2, oftentimes what will happen is they might say, hey, look what I did. And then that person they showed might say, well, have you thought about this? And so they go back, revise the study, do it again, go back, revise the study, do it again. And so more and more questions can be answered based off of these repetitions of an experiment. So to answer number 6, we can just say research studies often lead to revised or new questions to be investigated. And what about the question box? Consider this situation. This unopened bag of chips is half empty. I wonder if it really contains 28.3 grams as the package says. So it says this type of an informal question or observation is the beginning of many investigations. Informal questions can turn into more formal problem statements or research questions. For example, you may decide to investigate whether there is a scandal in the potato chip industry by checking the following. Do Lay's potato chips contain an average of 28.3 grams of chips per bag? Now, as a reflection, it says, now that you have been introduced to the research cycle process, think of some research questions that you are interested in studying. List at least 3 ideas of research questions. Consider the following. So you can have all types of questions here, depending upon what you are interested in writing. An example that I thought of was, do you always get 8 chicken nuggets in your Chick-fil-A order. So you go to Chick-fil-A, you order an 8-count nugget meal. Are you always going to get 8 nuggets, or sometimes you might get 7, sometimes you might get 9? So this is something that you can study or test to see if it's actually 8. And it says, what type of study, experimental or observational, might be the best approach to each of your research questions? So the question that I wrote, the best way would probably be an observational study. And the reason is because you can go to Chick-fil-A, order an 8-count nugget meal, and count the nuggets. Then again, later, maybe like the next day or whatever, however often you do it, you can do it again and again and again and just track how many nuggets you get each time. So for mine, it would be observational. Now it says, if you only have 4 weeks to actually implement a research study, is it possible to study any of your research questions? For mine, yes, it would be. And the reason is because I could go there every day if I wanted. I could go there twice a day or 3 times a day and collect a pretty good amount of data in just 4 weeks of time. The next question says, how can you change one of your questions to make it fit into this timeline? That doesn't apply to my question, so I'm going to skip that one. Question 8 says, suppose you conduct the investigation into Lay's potato chips and find that the mean weight of the chips in your sample is 25 grams rather than the 28.3 grams, or X bar equals 25. Do you think that the difference of 3.3 grams between the actual and advertised weights is large enough that it needs to be reported? If so, how do you report this information and to whom? So, if you are trying to figure out whether to report this or not, you just need to check and see if they're falsely advertising. If they say it's supposed to have 28.3 grams, then yeah, you need to report it. So you can say, if you believe they are falsely advertising, then yes. And it says, if so, how do you report this information and to whom? You could contact the news channel or a consumer watch group. So you can contact the news channel or a consumer watch group. Okay. Now it says, in some situations, researchers are even more formal and state hypotheses. In a case like this, the null hypothesis, generally, or HO, generally states that there is no difference between the true value and the claimed value. And the alternative hypothesis, or HA, states that something is different or incorrect, or that something has changed. Question 9 says, what are the null and alternative hypotheses for the potato chip example? So our null says the true mean weight, we can say, is 28.3 grams or more. And then our alternative, we can say the true mean weight is less than 28.3 grams. Now notice that the hypotheses say the true mean weight. This implies that the statements refer to the population of Lay's potato chip bags, not just a single bag or even a small sample. So we're looking at the entirety of all Lay's potato chip bags across the world, not just one bag or the amount that you test. We're looking at all of them. Now, when a statistical investigation is conducted, it generally employs a sample that is then used to make a generalization about the population. Notice that in this case, as in many cases, population does not refer to people, but to bags of potato chips. Now, to be concise, researchers often use symbols in place of words. Greek letters are usually used when referring to populations or the entire group being studied from which a sample or samples will be drawn. And English letters are used for samples or the particular items or individuals included in particular study. For example, when discussing the mean, mu is the population mean and x bar is the sample mean. So the hypotheses for a study can be stated in words or symbols. When using symbols, you must identify what your symbols represent. So our null, instead of all we're doing is we're just taking what we wrote right here for our null and right here for the alternative, and we're just putting them into symbols instead. So we can say the null hypothesis, mu is greater than or equal to 28.3 grams. And then our alternative, mu is less than 28.3 grams. Now, stat studies are designed with carefully selected measures that ensure, within error margins, that if the sample is well selected and the study is well designed and conducted, the mean and other measures of the sample are likely to be similar to the corresponding measures of the population being studied. So basically that just means that if this test is done correctly and accurately, then we can assume that it's true for all potato chips, all bags of potato chips. Now, sometimes if the population is small, such as high school seniors in a small town, it may be possible that the sample studied is the entire population. But often a sample is a smaller subset of the population, such as a research question that focuses on seniors for an entire state or nation. Now it says for questions 10 and 11, practice writing hypotheses. Write them in words and then convert them to symbols. And finally, sketch or outline a simple study design that might help study the hypotheses. So number 10 says a local pizza joint, Half-Baked, advertises an average delivery time of 20 minutes or less, but it does not offer a guarantee such as a free pizza. The national manager, Marky Mark, wonders if his employees are fulfilling this claim. So we need to write some hypotheses to help test this. So remember, our null hypothesis always says two things are the same or nothing has changed. So we can say true mean. For the null, we could just say true mean delivery time is 20 minutes or less. And for the alternative, we can say true mean delivery time is greater than 20 minutes. And now, to convert it into symbols, what we can do, we can just say for the null, the true mean, okay, remember we use mu for that, is 20 minutes or less. So we can say true mean is less than or equal to 20 minutes. And then the alternative, we said that the alternative was greater than 20 minutes, so we can say HA mu is greater than 20 minutes. And a way that Marky Mark could test this, we can just say Marky Mark could use data from secret shoppers. So he could just hire some people to say, go up to random people and be like, hey, order a pizza for me and tell me how long it takes to get to your house. And he could have a sample space of, say, 50 people. He could have 50 people do that, and then count how long it takes to get to his house and see if the average time is 20 minutes or less. Now, question 11 says, James believes that his mother's houseplants would grow taller if she watered with rainwater instead of tap water. So we're going to have two hypotheses, our null and our alternative. The null, remember, says that nothing has changed from the original statement. So we can say, for this one, the true mean height of plants watered with tap, I'm going to say with tap water, is less than or equal to that with rainwater. And then the alternative, we can say true mean height of plants watered with tap is greater than that with rainwater. And now for the, if we were just to convert this into symbols, we can say for the null, true mean for tap water, I'm going to put a little sub letter there, tap water is less than or equal to the true mean with rainwater. And then for the alternative, we can say the true mean for tap water is greater than the true mean for rainwater. Now it says not all studies lend themselves to hypothesis writing. For example, if Giancarlo is interested in cars, he might want to collect information about the most popular type of car among teenagers, the most popular color, or prices of various models. He would not design a study to test hypotheses. To test a hypothesis, he could write a test and test hypotheses. However, if he wanted to know whether or not the advertising for the gas mileage of a certain model is true. So for question 12, a reflection, recall the potato chips hypotheses. And here we have them right here, the null and alternative. And it says, what would you do next to determine which of these hypotheses is true? So just like we said earlier, we could gather representative samples of the chips, weigh the chips inside, and then find the average weight. So we can gather representative samples of the chips, weigh the chips inside, find the average weight, and report the results.